This video represents an important milestone in the Spor Argus development cycle, the hardware and mobile app working together to provide the entire user experience. We'll spend most of our time going over using the application, but to recap, the hardware we'll be interacting with is a combination GSM telephone controlled by a Bluetooth low-energy capable microcontroller. It uses an accelerometer to detect motion, GPS to determine its position, and has a host of nice features, like the ability to recharge the LiPo battery through USB. The mobile application is bare bones in terms of look and feel, but it's implemented in such a way that any competent web designer will be able to style it according to taste. It was created using a cross-platform development framework and is currently running on Android devices, but should be easy to get operational on other platforms like iOS. The mapping uses Google plugins and the rendering is very smooth. Here, the device senses motion while the user is connected and close by, so it moves to the in-use state. After a period of inactivity, it considers itself parked and can go into deeper sleep, unless it's shaken again. Though it's most comfortable on devices with larger screens like tablets, the application is set up to adjust to screen sizes and runs quite smoothly on small mobile devices. Here it is on the same phone, but in landscape mode. Motion triggers a change in state. These states I've been referring to are the various states in which the device is at any given time, represented by this state machine transition diagram. In essence, the hardware starts in the park state and goes to sleep after a period of inactivity. Motion triggers an awakening, and how the device reacts depends on whether there's an authenticated user close by. If so, then it is simply being used normally, shown as the green in-use state. If no user can be found, there's a short grace period where reauthentication is requested to any connected device, in yellow on the right. Failing that, the module considers the use unauthorized and begins reporting its position to the server through the cell network. In order to actually see what's happening behind the scenes, this development version has a debug switch in the account configuration. Turning it on will make a few debug output widgets available, namely in the device interface. This debug interface provides a set of action buttons and some raw output from the device, which is received over Bluetooth. The actions of most interest here are the mask on and off, which allow us to stay connected to the module while pretending we aren't, masking our presence so we can see what happens when we aren't around. Here we make a few configuration changes and can see what happened on the device side through the debug output window. Then the module is jiggled and moves into the in-use state. Now we'll mask our presence from the device and give it a bit of motion while it's parked. The device moves into the auth request state, demanding to know who is moving it around. After a while, we turn the masking off. When the next re-auth request comes in, the device does what it would do normally, requests a challenge and response, so the module knows all is well and moves into the in-use state. Notice that the device is checking that the user is connected and authenticated, but also that the person is in range. This will be important later. If instead of unmasking our presence and sending the reauthentication, we just let the grace period expire, the hardware eventually gives up and goes into alert mode, considering this an unauthorized use. When an alert is triggered, the hardware notifies the central of its position periodically. On the user side, a cancel alert button becomes available. This manual cancellation is optional but recommended. Assume a person has received an alert and is getting close, searching nearby for their bike. It would be unfortunate if simple proximity and automatic authentication were to cancel reception of position updates. This mechanism avoids the situation. The person can use their mobile to communicate with the device and still actually decide when all is well and that the alert mode should be cancelled. About proximity. The range of a Bluetooth low-energy connection can be up to around 100 meters in some cases. So the hardware differentiates between when the user is in communications range, the yellow circle, and when they're actually in usage range. This way, you can be sitting in a coffee shop nearby while still having your asset protected, even while the mobile is communicating with it. Thus, for a reauthentication to be considered sufficient, the signal must be coming from within the green circle. Because the signal strength is only a rough and variable indicator of distance, How the module decides whether you are in range is configurable through the settings panel in the device interface. Finally, because RSSI will fluctuate even for a stationary cell phone in a pocket, the system uses hysteresis and averaging to smooth out the fluctuations and minimize false triggers. Though there are certainly better ways to provide this information to users. Currently, the app will give you an idea of the determined range by scaling the size of the contents of the information panel as you change between the 3 zones. Larger fonts indicate that the module considers you nearer. You can see the effect of range determination here. The device has been moved and we're still connected, but outside the authorized use zone. The app does respond to the incoming re-authentication requests, but these are ignored by the module, as it is near impossible that the user is actually the one causing the disturbance. As we get closer to the module, the device detects our proximity, and on the next re-auth request, our response is accepted as valid, and the device relaxes back into parked mode. On a final note of interest, to date I've managed to keep the code size just under the limit to be able to do DFU transfers of the firmware. This means that in order to update the hardware's code, you only need a BLE-capable mobile device. No wires, no programmers, just a file in a few minutes. Well, this concludes the presentation and this milestone of the project. I hope you found it both enjoyable and informative, and await your comments and questions. Thanks.